discussing about the second experiment, that is to implement and design. Okay, design and implement the code converter, that is from binary to gray and from gray to binary. So these are the two concepts that is there in the second experiment. So this binary to gray we have already discussed. We have written the truth table and we have also written the k maps and we have got this equations. That is we have got this expressions from the k map, right? So now, the second concept is from gray to binary. So G to B means gray to binary. So how to convert the gray data to binary? So to convert the gray data to binary, you have to use this expression. So what is this expression? So B3 is equals to G3, B2 is equals to G3 XOR G2, B1 is equals to G3 XOR G2 XOR G1, and B0 is equals to G3 XOR G2 XOR G1 XOR G0. So by using this four expression, you have to fill this binary data. So now, how I have written this truth table? On what basis I have written this truth table is, so in the previous video, okay, in the previous video I have already explained how to write the truth table from binary to gray. In the left hand side I have written a binary data and towards the right side I have written a gray data, right? How I have written the gray data? By using this equations, right? By using this equations I have written the gray data. Same gray data you can copy towards the left side now. Okay, the table will get swapped. So whenever we are dealing with the second concept, the table gets swapped. So binary, so there I have written binary towards the left side and gray towards the right side. So now what you have to do, you have to write the gray towards the left side and binary towards the right side. Okay, the same thing you have to just swap it. It is a very simple work. Don't just think and write again the table. Okay, it is a bit difficult if you are thinking and writing from binary to gray or from gray to binary. So whatever the truth table or whatever I have taught in the previous video, the same truth table, you have to just swap it and solve. Okay. So now what is the concept we are understanding? We are understanding gray to binary, right? We are understanding gray to binary and we have to derive this expression by making use of the k map. So towards the left side there is a gray data and towards the right side there is a binary data. You can observe here, towards the left side there is a gray data and towards the right side there is a binary data. Don't be confused. So now I have to derive the expression for B3. Okay, I have to derive the expression and I have to check for B3. So how to check that? So first write down the k map. First write down the k map for B3. First write down the k map for B3. So what I have to write towards the left side and the right side? You have to write G3, G2, G1, G0. Okay, G3, G2, G1 and G0. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So what is the cell numbers now? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So these are the cell numbers, right? So now I have to get the expression for B3. So if I want to get the expression for B3, whatever the values that are there in B3, just copy down. Okay? So 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1. Right? So this is what it is there in this particular column. So now you just tell me how many number of groups are possible. As I have already explained in the theory classes, you have to check for the highest priority. That is whether it is having the octet or whether you are able to go for a quad or pair or isolated one. So if there are 8 ones continuously, either in a horizontal manner or in a vertical manner, blindly you can go for an octet, right? So this is an octet. Okay, this is an octet is possible here. So therefore I am going for an octet. And what is the expression that I will be getting for this particular group? The expression will be, so this, all these variables, that is G1 and G0 get cancelled because it is growing vertically, it is touching all the variables, so therefore G1 and G0 get cancelled. And if you just grow vertically, it is touching or it is mapping G3. It is mapping with respect to G3, and G3 is taking the value 1. So therefore, the expression for this particular group is G3. So now, therefore, I can write it as B3 is equals to G3. Therefore, B3 is equals to G3. So you have got this particular expression. So B3 is equals to G3, right? So now we will write down for B2. So if I want to write it down for B2, again you have to make again you have to draw the K map. Again you have to draw the K map. So that is B2. See 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay. So now we are supposed to write the content that it is present in the second column, that is B2 values. So 0, 0, 0, 0. Okay. Then 1, 1, 1, 1. Then 0, 0, 0, 0, 1, 1, 1, 1. Again there are 8 ones which are continuous, so therefore very plainly I can write down one more octet, and what is the expression or the value for that particular group? It is G2. Alright, it is G2. Okay. So now what is the value of B2 you are getting as? B2 you are getting as G2, but what is the expression you want? What is the expression you want? You want G3 XOR G2, no? But you are getting only G2. So now what to do? So what to do is, what is G2 from the previous table? What is G2 from the previous table? That is from the previous concept. That is with respect to binary to gray. So G2 is nothing but B3 XOR B2. Let me substitute here. B3 XOR B2. Can I write B3 as G3 from this? Okay, from this, can I write B3 as G3? Yes, I can write down. And what you have got just now, you have got B2 is equals to G2. Can I write B2 as G2 here? So therefore, I can write B2 is equals to G3 XOR G2. I repeat it once again, it is a very important concept, don't make a confusion here. So after writing the K-map for B2, I have got the answer as G2. But what is the expression that is shown here? The expression that is shown for B2 is G3 XOR G2. So how you will arrive here? So now I can write G2 as what? I can write G2 as B3 XOR B2 from the previous expression. That is from here. So now I will represent B3 as G3 because just from the previous K-map I have got B3 as G3, and just from this K-map I have got B2 as G2. So therefore I am going to replace B3 as G3 and B2 as G2. So finally your answer will be B2 is equals to G3 XOR G2. Right? So you have derived even this as well. Okay? Fine. So now you write down the K-map for B1. Write down the K-map for B1, all of you. Just the same concept, holds good. Don't be confused. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay. So now let me fill the data that is under B1 into my K-map. Okay. So 0, 0, 1, 1, 0, 0, 1. Okay. 0, 0, 0, 0, 1. Next again 0, 0, 1, 1, 0, 0, 1. So now if I group this, what is the answer you are getting? You have to eliminate all the G3 and G2 because if you map towards the left side, it is mapping to all G3 and G2 data. So therefore G3 G2 data very easily. And if you grow vertically like this, it is touching what? G1 and G2. Sorry, G1 and G0. So G0 get cancels because it is taking the value from 1 to 0, and G1 remains here. So here you are getting G1 for what? For B1. We are getting the K0 for B1. So now I will just explain once again. So B1 is equals to what? B1 is equals to G1 you are getting. Okay, B1 is equals to G1. But what is the value you want actually? See, the expression is G3, G2, G1. But you are getting only G1. So now again what I have to do? Again I have to look into the previous concept. What is G1? G1 is nothing but B2 XOR B1. B2 XOR B1. But what is B2? What is B2? B2 I can just write down as G3. Okay? B2 I can write it as G3 XOR G2. And what I can write B1 as? I can write B1 as just G1. Just now I have got the value from this particular K map. So B1 I can equate it to G1. So therefore I am writing it as G1. And this is the value that we are getting for B1. Right? So this is the value that we are getting for B1. So whenever you are writing this, just refer this equation and also the previous equation, then you will understand. Okay? Fine. So we shall come to the last part, that is a B0. We shall come to the last part, that is B0. Okay? If you just understand one particular expression, then very easily you can write by yourself. So whatever the values you have there, say 0, 1, 0, 1, 0, 1, 0, 1, then 0, 1, 0, 1, 0, 1, 0, 1. So this is what you have got it. If I am copying the value in the K map, so the expression is, so if you just observe the K maps of gray to binary, all the K maps is having the octet only. Okay. So what is the expression that you are getting for this particular group? So all these variables get cancelled, so therefore it will be having only G0. So now B0 is equals to what? You are getting it as G0. Okay. So now what is G0 from the previous concept? It is B1. Okay. B1 XOR B0. So what is B1 from here? B1 from here is G3 XOR G2 XOR G1. Okay, what is this B0? This B0 is nothing but a G0 from this particular K map, so therefore you are getting it as G0. So this is the expression for B0. Have you all understood how I have arrived to this particular equations? Okay, this is a bit difficult. Okay, compared to this particular concept, this is a bit difficult. Bit difficult in the sense you have to refer this expression and also this expression. Don't get confused. Just understand the concept properly, just write down the K maps properly, then you will surely understand. Fine. So now I have to start writing the K maps. I have to start writing the circuit diagram by considering these expressions. Okay. So now let me write down that. So let me write down the circuit diagram for that. So how to write down the circuit diagram? Just copy down properly the truth table now.